Hi there, I'm doing July 3rd. So I saw that the July 2nd video were truncated due to some system error in the recording software. Uh, anyway, I can tell it was not very interesting ending there. It was mostly that it went through and got it to link. And after that, I have started the next step in the same plan, which was to deploy and test it. I also asked a bit about the sizes. You can see here that actually Rust trims quite a lot on the space used. That's interesting in itself, but maybe it's over optimizing for space. Maybe it's slower, I don't know, but maybe it's because it also brings in core and alloc, which is 280 kilobytes and mostly just for panic formatting. So we can probably remove this, or anyway, it's shared. If you have a lot of Rust in your kernel, it's shared between all the Rust usages. So it's a 1% tax for all of the kernel. And if we do a lot of Rust, maybe we save bytes enough to compensate. But he also says that we don't actually need the panic formatting. We can probably call the C versions of printf and such, but yeah, I don't care too much right now. This is proof of concept. And where it stopped was that the table got overloaded. So I think I'm just going to say retry here. Okay, it was very close to getting done. Everything is done and verify. And the workflow had finished successfully right around the time the session exited. Okay. Final result, the Rust list is in a real kernel, booted, and it swaps. Yeah, what I wanted to do was to boot that kernel with the blist, Rust blist, so that it could be tested by swapping, since its only user is UVM swap. A real latent bug was found and fixed along the way. That's interesting. Oh, maybe it was a bug in the Rust drivers. Oh, that's not a bug in OpenBSD proper, but in my experiments. Okay, the kernel was tested with only 128 megabytes of RAM. And he made a C program, map 350 megabytes of anonymous memory, touching every page. So confirmed we're working. That was actually most of what I wanted to show, but maybe we should look at some code actually. Can we do that easily? Okay, it seems to be there. Rust null list rs. Let's see. Can I perhaps open it? Here they are. Okay, let's see for. Well, we can look at the glue first. Didn't I copy? It might be that copy doesn't work across the Docker. No, it doesn't. Let's see here if I can make it like this. There it said something. We have some special copy paste logic in this one. So, did you see what it said? If paste file, hold shift while selecting for native copy. Okay, we'll do that. Shift. I don't think it worked. It felt like it was exactly the same logic. I have been doing such things before here. Can I go inside a directory? Yes, I can. Okay, that's good. Then I can probably just say rust list rust source lib rs. So this is the glue. And the glue is basically just some external C stuff here. And then we can go into the actual Rust code. First, it's just a library file. Nothing interesting. Then here's the actual glue for the C callers. So we have external C linkage for all the entry points like list create. So this is converted to a C ABI method, which then does call a Rust list create with the number of blocks, and it boxes the, the response. Yeah, so all the C entry points is defined in FFI, and then the real code is here. And as you can see, it's quite normal looking Rust code. Yeah, of course, you can compare this to the C version. I think this is really readable, nothing strange. yeah, quite idiomatic, a lot of matches, which are good. And then there are tests, ordinarily looking. Yeah, that's about it really. So we have proven that Rust can be used to replace C code in the OpenBSD C kernel. And it was not too hard, but if you only make it to a few files, there will be a high tax of 1% to the kernel for the runtime, but that can be skipped. Yeah, that was all for today. Bye bye.